Hi students, I'm continuing the chapter application and derivatives, and today I'm going to discuss some problems related to maxima and minima. It's an important topic, so listen carefully. This is our first question. A wire of length 28 meter is to be cut into two pieces. One of the pieces is to be made into a square and the other into a circle. What should be the length of the two pieces so that the combined area of the square and the circle is minimum? So note the point minimum. Okay. So in this question we need to find out the length of two pieces. Okay, the condition given that the combined area of square and the circle is minimum. Okay, so let's start the solution of this question. Let one piece of length L be cut from the given wire to make a square. Okay, so if the total length, given that the total length of a wire is 28 meter, and let L be the first first piece of wire, and the remaining length of wire is 28 minus L, right? So this piece of wire, that is L, the length L, the piece of length L be cut from a the given wire to make square. Okay, the other piece of wire to be made into a circle, that is 28 minus L. Okay, total length of a wire is 28 and it cut into two pieces. First piece of the length is L, and second piece of wire having a length 28 minus L. Okay, so here L is the length of wire to make a square. That means the perimeter of a square is equal to L. And what is the perimeter of square? We know that if side of a square is A, then perimeter of a square is 4A, right? So it will be equal to the length L. So from this we get the side of a square is L by 4. So from this we get side of a square is L by 4. Okay. And let R be the radius of the circle. Then 28 minus L is the length of second piece of wire to be made into circle. That means the perimeter of a circle is equal to 28 minus L, and we know that the perimeter of a circle is 2 pi r, right? 2 pi r equal to 20 minus L. From this we get radius equal to 1 by 2 pi 28 minus L. So here side of a square is we get L by 4, and radius of a circle is 1 by 2 pi 28 minus L. So next, given that we need to find out the length of the two pieces so that the combined area, that the condition is that the combined area of the square and the circle is minimum. So the combined area of the square and the circle is denoted by A, and which will be equal to the area of a square plus area of a circle. So what will be the area of square? Area of square with side A is A square. That means side of the square square. Side of the square, all square is the area of the square plus, and we know that the area of a circle is pi r square, right? Pi r square. Okay, so substituting the value of side of the square, that is we get L by 4 here, all square. Here we get the area of the square plus next is the area of circle. So area of circle, we need the radius, value of radius. So substituting the value of r here, we get the area of circle as pi into 1 by 2 pi 28 minus L whole square. Okay. So taking this square on numerator and denominator, we get L square by 4 square, that is 16, plus pi into 1 by 2 pi all square means 4 into pi square, and 28 minus L the whole square. And here these two pi will cancel each other, and we get the area, combined area, capital letter A equal to L square by 16 plus 1 by 4 pi 28 minus L square. Okay. Next, we need to find out the derivative of area with respect to L. So that we need to differentiate with respect to L on both sides. We get dA by dL equal to derivative of L square is 2L divided by 16 is a constant. So 1 by 16 into 2L plus 1 by 4 pi is a constant into 28 minus L the whole square. That means we know that the standard derivative of x square is 2x. Here replacing this x by 28 minus L, we get the derivative of 28 minus L the whole square as 2 into 28 minus L. Here 28 minus L is another function, so we need to find out the derivative of 28 minus L using chain rule, and we get the value by derivative of 28 minus L is derivative of 28. 28 is a constant, and we know that the derivative of a constant is equal to 0, and derivative of L is 1. So don't forget to write this minus. So the derivative of 28 minus L is 0 minus 1. Okay. Here cut this 2 and 16, and we get L by 8 here, plus, and these 2 and 4 we get 1 by 2 pi here, and the value dA by dL we get L by 8 plus 1 by 2 pi 28 minus L into 0 minus 1, and these minus 1 will changes to plus into minus will changes to minus here. Okay, so L by 8 minus 1 by 2 pi into 28 minus L is the value of dA by dL. Okay, next by using second derivative test, we need to find out that d square A by dL square, right? So differentiating this again with respect to L, we get L 1 by 8 is a constant, and the derivative of L is 1, minus 1 by 2 pi is a constant. Derivative of 28 is 0 because 28 is a constant. So derivative of constant is equal to 0, minus derivative of L is 1. So we get d square A by dL square as 1 by 8. This minus and minus will become positive. So 1 by 8 plus 1 by 2 pi, and this is a positive term and this is a positive term. The whole term is positive. So this is minimum. Okay, the condition already they have given the combined area is minimum. So we get here, now we get here the combined area is minimum. So next we need to find out the critical point, that putting this dA by dL equal to 0, we get our critical point here. 1 by 8, that is d value, substitute the value of dA by dL equating to 0, we get this step. So L by 8 minus 1 by 2 pi 28 minus L equal to 0. Okay, and cross multiplying this term, we get 2 pi L minus 8 into 28 minus L whole divided by 8 into 2 pi equal to 0. And denominator term goes to the RHS, and it will become 0, and we get 2 pi L minus 8 into 28 minus L equal to 0, and dividing throughout by 2, we get pi L minus 4 into 28 minus L equal to 0. Okay, and taking this term into RHS, it will become a positive term, and multiplying after opening this bracket, we get 4 into 28 is 112 minus 4 into L, that is minus 4L. Pi L equal to 112 minus 4L, and taking this minus 4L to LHS, it will become pi L plus 4L equal to 2 pi L. From this we get L is a common, and taking outside we get L equal to pi plus 4 equal to 112, and from this we get L equal to 112 divided by pi plus 4. So this is the critical point, or we get when L equal to 112 by pi plus 4, d square A by dl square is greater than 0, that is minimum. Okay. So by second derivative test, the area or combined area capital letter A is the minimum when L equal to 112 by pi plus 4. So L, don't forget that L is the length, piece of length L we cut from the wire of 28 meter to make a square, right? Next we need to find out the other piece of wire, length of other piece of wire to be made into a circle, and whose length is 28 minus L. Okay, so 28 minus L. Here the value of L that we have get already as 112 by pi plus 4, right? So substituting the value of L here, we get 28 minus 112 by pi plus 4. Cross multiplying, we get 28 into pi plus 4 minus 112 divided by pi plus 4. And opening this bracket, we get 28 pi plus 28 into 4 is 112 plus 112, and also write minus 112 here, whole divided by pi plus 4, and cancelling these plus pi, 112 and minus 112, we get 28 pi by pi plus 4. So this is the length of the wire in making the circle. Okay, and L is the length of the wire in making the square, and we get L as 112 divided by pi plus 4. Okay, I hope you understood. This is our next question. Show that the right circular cone of least curved surface and given volume has an altitude equal to root 2 times the radius of the base. Okay, so note that here given that the least curved surface area. Okay, so let's start the solution of this question. Let R is the radius of the cone and H is the height of the cone. Okay, and let us look at this figure. Here L is the slanting height. Okay, from this we get L equal to L square equal to, so this is a right angle triangle, so L is the hypotenuse, right? So L square, using Pythagoras theorem, we can write it as L square equal to H square plus R square. Okay, and we know that the volume of the cone is 1 by 3 pi R square H, and from this we moving this 3 to LHS, we get 3V equal to pi R square H, and from this we get H equal to 3V divided by pi R square, and note that H is the height of the cone. Okay, so here given that the surface area is minimum, so we need to check it, it is for minimum, so that we know that the surface area of the cone is pi RL, right? Okay, note that L is the slant height, so pi R into L. From this we get L equal to root of H square plus R square. So substituting this by this, here we get pi R into root of R square plus H square. Okay, next I am going to substitute the value of H here. Value of H is 3V divided by pi R square. So substituting the value of H here, we get 3v divided by pi r square. Okay, so our surface area will become pi r root of r square plus 3v divided by pi r square the whole square, and taking this square on both numerator and denominator, we get 9v square divided by pi square r square all square means r raised to 4. Okay, so cross multiplying these terms, we get pi square into r raised to 4 means r raised to 6, that is here, plus 9v square whole divided by pi square r square. Okay, and root of pi square r raised to 4 means root pi square means pi. So taking this pi square and r raised to 4 out, from outside from root, we get pi square, root of pi square is pi and root of pi r raised to 4 is r square. So pi r divided by pi r square into root of this numerator will remain same, that is we get pi r divided by pi r square into root of pi square r raised to 6 plus 9v square. Okay, and cancel these 2 pi and this 1 r, and we get 1 by r root of pi square r raised to 6 plus 9v square as our surface area. Next I am going to find out the derivative of surface area with respect to r. So differentiating with respect to r on both sides, we get ds by dr. Here 1 by r is one function and root of pi square r raised to 6 plus 9v square is another function. So using product rule, and we know that what is product rule? uv whole dash is equal to u into v dash plus v into u dash, right? So here u is 1 by r and v is this term. So first term into 1 by r into first function into derivative of second function. Derivative of second function means we know that the standard derivative of root x is 1 by 2 root x. So replacing this x by root pi square r raised to 6 plus 9v square, we get root derivative of root of pi square r raised to 6 plus 9v square as 1 divided by 2 root of pi square r raised to 6 plus 9v square into, here this is another function. By using chain rule, we need to find out the derivative of this term also. Okay, so I am going to write here and plus second function into this second function into derivative of first function. We know that the standard derivative of 1 by x is minus 1 by x square, but here we need to find the d by dr of 1 by r, so it will become minus 1 by r square here. Okay, so here the derivative of this term remains same, and derivative of this term is, here pi square is constant and derivative of r raised to 6 is 6r raised to 5, and we know that standard derivative of x raised to n is n into x raised to n minus 1, but here it is r raised to 6, so here in place of n 6 is present, so the derivative of d by dr of r raised to 6 become r into r raised to 6 minus 1, that means 5, right? So pi square into 6 into r raised to 5 plus 9v square is a constant, right? So derivative of constant is a 0. Okay, and this minus will plus into minus will become minus here, and we here this term will changes to 1 by r square into root of pi square r raised to 6 plus 9v square. Okay, next I am going to here r square is present in the second term of denominator of this function, and here r is present, so here we need to multiply with numerator and denominator by r. So here r divided by r square we get r divided by r square term here, and also 1 by r square is also present here. So here 1 by r square is common in both two terms. So taking outside, we get 1 by r square into r divided by 2 root of pi square. Just a minute. Okay. Taking multiplying this r on numerator and denominator, so it will become this on this part of question will become 1 by r square, right? So by taking this 1 by r square on both sides, we get 6 pi square r raised to 5 into this r will become r raised to 6 whole divided by 2 root of pi square r raised to 6 plus 9 v square. Okay, and minus also 1 by r square is taken outside, and the remaining term is root of pi square r raised to 6 plus 9 v square. Okay, so next I am going to cross multiplying this step. We get first of all I am going to cut this 6 and 2, so it will become 3 pi square r raised to 6, and then cross multiplying we get 3 pi square r raised to 6 minus this root into root will cancel, so we get minus pi square r raised to 6 plus 9 v square whole divided by root of pi square r raised to 6 plus 9 v square. In this step, we know that root x into root x is x, right? So this root term and this root term, the product of these two root term, this root will cancel. Okay, so we get this step here. Next 1 by r square, here I am going to open this bracket. We get minus pi square r raised to 6 and minus 9 v square. The all other term remains same. Okay, next 3 pi square r raised to 6 minus pi square r raised to 6 will become 2 pi square r raised to 6 minus 9 v square whole divided by 1 by r square. This r square is comes to the denominator, right? So r square into root of pi square r raised to 6 plus 9 v square. So this is our ds by dr. Next I am going to find out the critical point, putting ds by dr to 0. So this term, I am equating this term to 0 and putting all the denominator to RHS, the whole term will become 0. Only left is 2 pi square r raised to 6 minus 9 v square equal to 0. From this 9 v square, I am taking this 9 v square to RHS. It will become positive 9 v square. And from this r raised to 6, we get r raised to 6 as 9 v square divided by 2 pi square. Thus it can be easily verified that when r raised to 6 equal to 9 v square by 2 pi square, the second derivative is greater than 0, because it have already given that the curved surface area is minimum. That means the second derivative of curved surface area with respect to r should be greater than 0, right? So we get the critical point r raised to 6 equal to 9 v square by 2 pi square. At this point, the critical point should be greater than 0. Okay, so it is given in the question. Therefore, so in this question we need not find out the second derivative. So it's already given that it should be minimum or it should be greater than 0. So therefore by second derivative test, the surface area of cone is the least when r raised to 6 equal to 9v square by 2 pi square. Okay. So, next, when r raised to 6 equal to 9v square by 2 pi square, from this, taking this 2 pi square to LHS, we get 9v square equal to 2 pi square into r raised to 6. From this, v square equal to taking this 9 to RHS or denominator, and v equal to square root of this term. Okay, and h we have already calculated that h equal to 3v by pi r square, right? So substituting this v2 here, I'm substituting here. Here we get root 2, taking this half to raised to half to all this term inside the bracket, we get root 2 pi square raised to 1 by 2 means pi, r raised to 6 whole raised to 1 by 2 means using law of exponent, that is x raised to m whole raised to m is x raised to mn, right? So r raised to 6 whole raised to 1 by 2 means it is changes to r raised to 6 into 1 by 2, right? Whole divided by 9 raised to 1 by 2 is root 9, that is 3. Okay. So here's cancelling this, we get r cube here. So the final answer 3 pi r square root 2 by 3 into pi r cube. Here cancelling these 2 3 and these 2 pi and this r square 2 here, and we get root 2r. Only left is root 2r and we get h equal to root 2r. So we can say that for a given volume, the right circular cone of the least covered surface area has an altitude, that is h, is equal to root 2 times the r or radius of the base. Okay, we have showed h equal to root 2r. I hope you understood this question. It is seemed to be a very a complex question, but this type of question is very important. So you need to practice well and do this type of question.